The match pairs case is pretty straightforward uh, in terms of what you do in the calculator. The setup is a little bit different because it's not a simple mu equals this, mu equals that. So we do have to kind of parse that information. The alpha values, same as it's always been. Significance level, that's our benchmark. We want to test the claim that there is no significant difference. Now, we have a before and after. So the before case we consider to be this entire group is a sample that would eventually lead us to mu sub 1. And the second group is a sample that would eventually lead us to a conclusion about mu sub 2. All right, so what they're asking us to do here is to prove or disprove that there is no significant difference. If something has no difference, it means that they're equal. So they're asking us to show that mu1 and mu2 are equal to one another. All right, so that's a null hypothesis. So this is the first instance where the alternative hypothesis wasn't the thing given to us. So we have to come up with that. All right. The alternative usually is given to us, and we just basically state that the null is whatever the alternative is, just with an equal sign. But here we're stating that the alternative would be the exact opposite of the null. All right, so it's a little bit of a departure. It's the idea of, well, what would be true if the null was not? All right, well, if the null's not true, I don't know if it's more or less. I just know it's not the same. Okay, that's what this symbol means. Not the same. All right, I don't know in which direction it's not the same. I don't know if before is more than after or before is less than after. I just know it's not the same as after. And that's all that matters. All right. Wonderful. Listen, I always thought to myself, you know what? If I could do anything I wanted to do on a Saturday morning, it would be, you know what? Let's go teach a stat class for 4 hours. Oh, you're welcome. That's my last time doing it. No, I'm retiring from it.
You work in the very last class is the privilege to see you every Saturday morning.
Yeah. Well, actually, some might look at that the other way. Like, oh, we're the class that made him not want to do this anymore. In which case, you should be giving me something. I don't know. The really well thought out, obnoxious yawn in my direction. That makes me feel like a champ, you know? Yeah. You know, like, I stifle, I gotta say, a yawn every 5 seconds for a period of 4 hours straight.
With serious powers.
Yeah. It's painful. Painful stifle.
Wait, so are you just not going to teach at WCC anymore, or just not teach Saturdays anymore?
Never again. No, no, I'm only going to do 1 class a semester from now on. And so that'll be during weeknights.
Professor, I have a question. Out of my 6 classes, 8 event is the only one that I enjoy.
Oh, I appreciate that.
Only to hell with the rest.
I appreciate that. There you go. I'm still never teaching on a Saturday morning. I've been doing it for like 15 years and I can't do it. I just bang my knee and that's the icing on the cake.
Where do we do your, how good you feel?
Oh, I'll send out a survey in like a week or so. The college one, they just select 1 class out of the ones that I teach. They took my weeknight class. So I'll give one from B that you guys can fill out. So it's more meaningful anyway. Yeah, just give me a little time to learn that stuff first, and then I'll go ahead and I'll teach it all. Yeah, that's what I'll do. You know? So I'll just start in the morning in like the academic arts building, and I'll just kind of migrate from building to building throughout the day, and do a little world history.
I was talking about you at Empire State College. I'm studying classes there in January, and I was talking about it.
All right.
Might get a call from the college.
But the colleges don't pay enough. That's what the issue is.
Are you still recording? Because you could actually send this to the dean and just be like, yo, I need your job.
Here's something. This I can't record. Yeah.
There's some other guy who's right on. He's not right on, but he's not close. He's like 3.
He's in the he's in the conversation. Yeah. I mean, there's plenty of good ones.
I told you that I registered this class on Monday and Wednesday for a different professor, and the first day I'm like, no, this guy just get it all. But you guys take this class by yourself, don't take it for another classes because you was I'm that tough. Bye-bye.
In your experience, it definitely depends on the district that you teach in high school. That's why you're a hot team, you know?
I think the first period is going to be out of luck, but the second period I have a chance. So data goes in L1 and L2. Now, we have our null and alternative hypotheses. What we need to do is run a t-test on this. Now, we've already looked at the t-test. And so we're going to come back to this menu, but let me just show you what the story is here. So don't actually leave here. Just stay in your stat editor. I'm going to go away for a second, though. Stat test option 2, the t-test, same as before. Remember it said data versus stats, and I said, well, we didn't type in data, so why would we put data as our option? Well, now we just typed in data, so we do need to put data in as an option. So I'm going to click on that. I'm going to hit enter on that, and then you'll see it asks you for a list, a single list. And I'm going to put it back on stats because that's where you guys are at, but I need a single list from this information. That's the moral here. So in my stat editor, somehow I have to take these 2 lists and make them into a single list. All right, so how do I do that? Well, test the claim that there is no significant difference between, doesn't matter what it is, difference, okay? That seems like a keyword. So what I'm going to do is I'm going to go over to L3. I'm going to hit enter on L3 itself. So the cursor, I'm going to put that right on top of that L3. I'm going to snip that and put it in there. So hit enter on it. And you see your little blinking cursor will be at the bottom of the screen. What we're going to do is create a rule for this entire column. All right? It's kind of like Excel. You can apply rules for single entries, or you can apply globally for an entire set of data. So by hitting enter on L3, I can now refer to entire columns. I'm going to say L1 minus L2. So second 1 minus second 2. All right, let me snip that in there. And again, it's second 1, second 2 with a minus sign. Wrong thing, because that's not a calculator. Enter. And it's going to apply the change wholesale. So it's going to subtract each L2 value from the corresponding L1 value. All right, so now I can ignore everything in L1 and L2 and only focus on L3. So when I go into my stat test menu, I'm only referring to L3 because that's only referring to the differences between the two sets of data. And that's really all I need because I want to know that there's a significant difference between the two. Now, difference could take a variety of different forms. You could have a positive difference, you could have a negative difference, or you could have no difference. All right? I'm testing the claim that there's no significant difference. I'm looking at just these entries here. I don't see a case where there's no difference. No difference would be a difference of 0. I mean, I see some cases where it's pretty close to no difference, negative 0.064 or 0.036, but I don't see a case where it's actually equal to 0. But again, this is a bat signal thing. All right? What I want to know is there enough evidence from what I have in my sample here to say that it's true about the entire population? Now, this is a flawed example, just like that Peyton Manning example was flawed, because can I draw a conclusion about the entire league just based on information related to a single team? No. Can I draw a conclusion about an entire set of quarterbacks based on information related to a single quarterback? No. And the reason why is because there's a lot of variation among the individual, not so much variation among the group. Right? So, it depends on, like quarterbacks, it depends on what quarterback I take. If I take the crappiest quarterback in the league, my outcome from the analysis would be that all quarterbacks suck. Right? But if I take the best one and be like, oh, they're all wonderful. So can I draw conclusions about everybody? No, but maybe I can make a conclusion about the Giants themselves only. All right? That's where this kind of goes. So anyway, stat test option 2. We had a choice again of data or stats. The last time we used stat test 2, we selected stats because we had no data. So hit the left arrow to select data. And we have to make some changes here. All right? The null hypothesis is no difference. All right? Mu1 equals mu2 is the same as no difference between mu1 and mu2. So that's going to tell us that our null should be 0 because in this context, that mu sub O represents the difference between the two entries in my null. All right. My list is L3. Frequency you leave at 1 because I didn't have any indication that any of these values are happening more than once. Like the 0.4 and the 0.364, that's one ordered pair, another ordered pair, and so on. So I don't have any reason to change that. And you won't have any reason to change that either, so that's probably more important for you.
Wait, so what if you just cross out where mu not equals 5?
Yeah, that's going to be, because the 5 was from the last problem, we're going to make that a 0 because that implies no difference, 0 difference between the sets. Okay. All right. It's a not equal symbol because that's consistent with our alternative hypothesis, and then we go to calculate. So second 3 to get your L3. So 0, L3, not equal, and then go to calculate. I'll get this calculator out of the way in a sec. All right. So What are we looking for? Same thing we're always looking for, the p-value. A lot of other stuff that's there. That's also meaningful. I don't want people to walk away thinking that the other information is useless. It's useful. It's just not for us because we're using a particular method. Like that t-value, very useful information. Just we're using the p-value approach, so all I care about is the p-value. Again, if the p-value is less than alpha, you will reject your null hypothesis. All right, so my p-value is approximately 0.451. We want to know, is that going to be less than, I lost it, where is it, 0.05? That is definitely not the case. So no. So do not reject HO. So we keep HO and we kill the HA. All right, so don't reject the null hypothesis. That means that we're keeping the null hypothesis. We're discarding the alternative hypothesis.
What is, so the alpha is 0.05, right? The significance level?
Yeah. So there is insufficient evidence to reject the claim and we state the null hypothesis in words. So the HO, I'll just write it again. HO is that mu1 equals mu2. But in words, that was that there was no difference in population, whatever it is. Sometimes proportions, sometimes means. In this case, means. Reject the claim that there is no difference in population mean, winning percentage. You can be more specific if you want, but I think that gets the job done. We know we're talking about a team. Specific, the data points to the fact that it's New York Giants. Talks about before and after a bye week, whatever the hell a bye week is. You don't need to know that. All right. The fact that we've addressed that we're talking about a difference in population mean winning percentage, I think we've gotten the job done. But the more specific you are, the better off you're going to be in terms of your comfort level. All right. But this is good enough for me. All right. This tells the story. Specifically at the 0.05. Oh, that should be in blue if I'm staying consistent. Significance level. All right. I'm not going to write a second sentence here in my conclusion. All right. The reason why, and sometimes you have to write it in order to realize you didn't need to write it. The reason why is it's irrelevant. Because they asked me, test the claim that there's no significant difference. There is insufficient evidence to reject the claim that there is no, well, I didn't say significant difference, but nobody's going to lose any sleep if you don't write that. You know, so I'm actually, that's not true. I'm sure there are plenty of people in this building somewhere that'll fly off the handle if you don't write significant difference, but that's because they have nothing better to do with their life. So there is insufficient evidence to reject the claim that there is no difference in population mean winning percentage. I've answered the question. Right? If there is insufficient evidence to reject it, it just implies that I'm keeping it. If I were then to write, therefore, the claim of a significant difference is true or false or otherwise, my first response is, whose claim was that? I remember that being in the problem. Nobody was claiming that there was a difference. So, if you were to write, for example, therefore the claim of a significant difference is true, you wrote something that didn't need to be there, and it's also incorrect. Because it should be false, but you wrote true. So that's what I was talking about before, where you would lose credit for something that you didn't need to do in the first place. Personally, I mean, there's nothing worse for me as a student taking a math test.
Wait, what was that last part?
Nothing worse for me
No.
as a student
What was the...
taking a math test. No, the second sentence addresses the alternative hypothesis, and it would be, therefore the claim of a significant difference is false, not necessary because nobody was asking about that. If you wrote it and you wrote it incorrectly, you'd be on the hook for it, so don't write it.